Okay, so we're back. Okay, so we'll stop the item here when the debugger. Okay, so I'll just do a bit of clear all my drawings. Okay, so the next question is, how do you control the rotation of the stepper motor? So we all know that the previous video can operate the stepper motor driver and drive the motor. The question is, how can you set the number of rotations for a specific stepper motor? Okay. So the answer lies with the ability of the motor. Okay. So motors themselves have a minimum step rating. Okay. So how many degrees per each step? So remember that a full rotation is 360 degrees. And most motors will actually have a 1.8 degree step accuracy. So that means for every 200 steps, we get 360 degrees. Okay. So if you want to move the motor one full rotation, you just need basically 200 pulses. Okay. So that being said, okay, we'll okay. So I'm now back into the annotation mode. Don't know why. Okay. Napindot ko yata. Okay. So if we go back to this general project, okay, so let's save the project as okay, stepper, sorry, right click, new folder, stepper, count. Okay. So I've just saved it as a different file. Okay. So let's proceed. Okay. So the next action is to include something or a structure that can benefit us. Okay. The structure is a functional block that we call as counters. Okay. So it should be on the counter natin. Okay. So it's a standard block. So most of the counters will have this sort of action. Count up or count down. In this case, we're just interested in a count up. So the count up signal is the indicator that we're starting count up function. The reset is for the counter to be reset. Okay, so we can restart the process. And then we have the PV value or the estimated number of counts that we need. So that can be addressed by the variable. So in this case, we just write in 200 kasi it's just a count. Okay. So yun yung 200 na count natin for the PV. Let's connect. And in this case, we'll add in a little bit extra something here. We'll add in another control structure here for the clock. So if there is no clock, there is actually no movement for the device itself. Okay. So we just need to add in the list natin an R3. So internal relay 3 na siya. So this internal relay 3 can be connected across the terminals for the clock so that we can actually make it in such a way that it doesn't bother anyone, doesn't mess around with the original uh, structure that we have. Okay. But again, this is negated. So in a normal series of events, it really doesn't do anything. Okay. But once you've reached the 200 uh, position, or you've reached a count of 200, then you can say that you've reached 360 degrees. Okay. So this is my count 0 value. Just bring this one down. And my variable output is again R3. So in this case, we'll be using two inputs in order to stimulate or to trigger the counter natin. Okay. So the first one would be the enable on. We'll set this one for CU, count up function. And then we'll have another one which we will use for the reset. So in this case, stop. Okay. So take note, my stop button here is not negated because if in a normal condition, the reset pin should not be set to a high value. Okay. So we'll add in two rails on the left side. Okay. And then we'll add in another item here onto the right side. Okay. So in this case, we'll have the actions already set for this one. So we're basically counting the number of pulses that come in. Okay. So yung counter position natin is mandated or operated by an on. So if this is on a high function, we should be able to count. Okay. Now what we're missing is the clock. So there should be, I forgot to place one, a clock here. And that clock is sequenced towards the count up value that we have. Okay. So when we start the simulation exercises for this one, okay, notice that R3 bool is not present here. So we basically have to do a save and do a reload possibly. Okay. So let's close the project. Let's open the stepper count project. And the R3 boolean is already there. Okay. R1, R3, direction, enable clock, enable on direction, which is and stop, which is our operating parameters or our operating inputs. Let's do a simulation. So again, since N on is all is basically not functioning, we don't have any activity. So in this case, I'll now look into the receiver, the current value of the uh, counter. So it's 0. Okay. So now what we will do is we will now trigger the system. Set this one to a toggle value of 2. And basically you can see the counter values go up. At a specific point, what will actually happen when it's 200 is that R2 and R1 are still going, but the clock output we have, we don't see anything coming out of it because R3 is now open. and there is no movement of signals going into clock, okay, basically. So when there is no clock pulse applied to a stepper motor, you should have no operation going into that one. So when we set the value to of stop to 2, we reset the counter, and then when we put it back to high, once to the open condition once more, you can see it will should be able to restart. So that's about it. So if you need uh 2 full rotations, you just change this one to 400 and you're basically done. So start the simulation, toggle to. So we just wait for it to arrive at a 400 mark. So this kind of gives us a idea now on how to go about for a addressable programmable value, okay, rather than a fixed value that you can have in a circuit. So if you can perhaps change the value here into something else entirely different, you might end up with a value that you can work with. Okay. So that is for another video.